NELA, the Nuclear Energy Leadership Act, was introduced last month by the Senate Energy and Natural Resources Chairman Lisa Murkowski. It further shows that not only can nuclear and clean energy policy more broadly be bipartisan, it can be supported for many different reasons, whether it's to address carbon emissions, our national energy and energy security, or just to ensure that America remains at the forefront of next-generation zero or low-carbon power sources that will dominate the global export market in the coming decades. At a 50,000-foot level, NELA does a few things to move nuclear forward. First, it starts with the end in mind, endorsing a grand challenge approach at the Department of Energy by instructing DOE to develop Moonshot research and development goals for advanced nuclear, as well as a new strategic plan for the first time in nearly 2 decades. Second, to support that research push, it provides the key tool needed by our nuclear innovators to develop their designs by authorizing funding for the versatile test reactor that was supported in the NELA law earlier this year. Third, once those designs are ready to be built, it allows government to put its electricity purchasing power to work to help demonstrate advanced reactors. Government entities could engage in longer-term power purchase agreements up to 40 years, more in line with the power profile from a nuclear power plant. And it also authorizes a pilot PPA program for new advanced reactors, especially for those providing national security or resilient services to the grid. Fourth, it ensures that advanced reactors will have the advanced fuel they need to run by authorizing an interim supply of high-assay, low-enriched uranium fuel, otherwise unavailable from the private sector. Fifth, and last but not least, NELA reauthorizes vital university nuclear engineering programs so we have the top talent to design, build, and operate advanced reactors. Taken together, NELA is a soup-to-nuts package of DOE ideas that have the potential to keep America ahead in nuclear energy.
In the advanced reactor sector, I'm afraid, but I have to say that I think the U.S. is starting to fall behind. As Rich has mentioned, there are countries that are already, developing these technologies. And, quite frankly, some of the countries that are leading in this space are not the countries that are particularly share the values and norms that the United States upholds. And to China, nuclear is their national focus, both for R&D, but then also for export. It has a sort of state finance tool that many OECD economies lack when they try to export their technologies, whether it's the conventional size light water reactors or advanced reactors in the future. Also Russia. Russia is actually already an established supplier in this current generation of fleet, but they're also looking at this nuclear as a strategic business. Their foreign ministry is in charge of promoting exports abroad. It's a very different setup from what we have in the US currently. They're also looking at small modular reactors certainly for deployment, but likely for exports as well down the road. And to look at this sort of a linkage between nuclear commerce and foreign policy influence from a different angle, as relates to the U.S. Currently, we have many light water reactors around the world that we've sold, and which have augmented our ties with these economies around the world. As these reactors do have to get retired in the coming years, or perhaps maybe decades for some of them, but if we do not have advanced reactors to offer as replacement, and if other economies come in, the foreign policy influence that we currently enjoy could be offset.
Many of you in the room know the value proposition. It's about reliable, resilient, clean energy for the future. And so the promise of advanced nuclear reactor systems in particular is quite exciting, an opportunity for the United States, I would argue, to actually leap back into a leadership position, go forward. As Rich mentioned, one of the key parts of NELA relates to Moonshot and tying quantitative measures and goals to enabling advanced nuclear energy systems. So as is mentioned in NELA, there's many aspects of advanced nuclear systems that we're interested in, right? It's It's less waste production, less spent fuel production, more reliable, more efficient, more accident-tolerant fuels, more proliferation resistant, all these systems level goals. But the other thing that I will mention in particular is economics, right? If we're serious about enabling advanced nuclear, we're going to have to drive down costs at the system level and the subsystem level as well. And so the idea of putting together for the Department of Energy Office of Nuclear Energy a Moonshot type goal where you're going after demonstrating advanced systems urgently in the next decade, which is very aggressive, but I think important for the United States to maintain leadership, but also tie that to concrete opportunities to cut costs and also make the systems more efficient. A lot of the metrics that we're talking about with safety, security, spent fuel yield, and cost are inherently measurable. So you could imagine, not that the Department of Energy doesn't do this already, but I think we can be much more rigorous about tying concrete goals to our R&D programs that are conducted at the laboratories and the universities in cooperation with industry. So I think that's a huge step forward, as Rich mentioned. Asking the department to sit down and write that down in a strategic plan, deliver that, and then manage to it, I think is a really, really important step forward. If you look at the testing capabilities in the United States, you look at a lot of the advanced nuclear reactor systems, several of the concepts are operating in the fast neutron spectrum, as opposed to the current fleet, which is a thermal neutron spectrum, slower neutrons. So currently the United States does not have a fast neutron testing capability, right? We had EBR-1, EBR-2 in Idaho, and we also had FFTF, the Fast Flux Test Facility at the Hanford site in Washington. Those capabilities have since left. So right now, if a US-based company or university or lab wants to go and test in the fast spectrum, they're faced with going overseas to places like China and Russia to find that capability. So the Office of Nuclear Energy, through the Nuclear Energy Advisory Committee a couple years ago, actually did a robust analysis of should we fill this gap in the United States with a fast testing capability. And the determination of them at the time was, yes, the Office of Nuclear Energy should start to explore that. And so that got authorized again in NECA and again in NELA. So we are working, Idaho's working with Oak Ridge and Argonne, Los Alamos, and P&L in the lab space. We've got university partners, industry starting to get engaged. In fact, just about an hour ago it went public. We've signed a contract with GE Hitachi to come in and help us with the design process. We just signed that contract late last week. So it's getting serious. We're starting to ramp up, moving into a conceptual design phase. For those of you who speak DOE project, we're operating according to the 413 order, so we'll go through the critical decision process. We'll be delivering critical decision 0, which is a mission need for the versatile test reactor in January, and then we'll move very quickly into the design phase. This is going to require resources, but we've got a team built that we think can be quite successful. And that will allow us to test a wide range of materials, fuels in the fast spectrum, and really will be an important part of maintaining that R&D leadership in the United States.
NuScale Power, as Rich mentioned, we're developing a small modular light water reactor. We're one of the older of the new advanced reactor companies. We were formed back in 2007. And so far, we've invested about $800 million into our design, both licensing and engineering for it. And we are looking to have our first plant operational in 2026 at the Idaho National Laboratory, which this gentleman knows very much about, and would be owned by Utah Associated Municipal Power Systems, a joint action agency headquartered in Utah. But one of the key things that UAMPS is finding is that, basically they use all the power for their members. And when they do that, having that ability to work with the Department of Energy and other federal agencies to take a portion of that output from a plant by way of a power purchase agreement is a key de-risking element as they look at it going forward. So the fact that we can go from a 10-year to a 40-year PPA and the possibility of under NELA having pilot power purchase agreements to go after those elements of advanced reactors that people are looking for, whether it be resiliency, whether it be hybrid energy, whether it be other types of attributes, is important to have that ability for the federal government to do that. I can't mention how important it is for UAMPS. I've been actually out to the UAMPS membership. There's been over 100 public meetings with town councils and other local bodies. And the minute we start talking about the potential for Department of Energy, PPAs, and the government support, it's very instrumental to their decision to be moving forward.
Modern reactors, or existing reactors rather, use enriched uranium that's generally enriched below 5% U-235. The reactors going forward are looking at using between 5% and 20% enriched uranium. So it's a really different framework than what we're working with now. And the problem with that is that there really is no existing capability to produce this fuel. But the fuel is necessary. It's necessary to have demonstration plants that can get up and running, and it's necessary to demonstrate that these advanced designs can be commercial, that they will work, and that we can move forward with creating our advanced reactor designs and commercializing them. In terms of the commercial side, it's expected to take 7 to 10 years to get the capability up and running to produce high-assay, low-enriched uranium fuel. But the DOE has more availability to produce that material because they have stocks of HEU, and they have a variety of other ways of producing it. So what this bill does is it sets forth a goal, or rather a mandatory amount of HEU that the DOE will produce using either its stocks of high-enriched uranium or its existing high-assay LEU. This is a great start. It gives advanced reactors the ability to demonstrate what they can do and to just get that ball rolling. There are still some requirements before we move on to the commercialization of HALEU. More on the NRC side, there's going to have to be looking at the transportation casks. They're going to have to evaluate whether or not there's going to be new transportation casks or whether you would use high-enriched uranium transportation casks. And there's also the NRC is going to have to take a look at their materials, controls, and accountability and security requirements and really modify some of that going forward. But this is it's a great start to get off the ground and running and to take a look at what advanced reactors can do.
But when you look at putting out the first of anything, it always costs more. It's just the way it is. And the question is, nobody wants to pay more for the first one. They want to pay the nth price. They want to pay what everybody after him is going to pay. And in the case of UAMPS or other customers in the market, they look at that being really the alternative for a natural gas combined cycle plant. So if you look at the gap of a first of a kind NuScale plant to an nth of a kind or to a gas plant, there's maybe about a $20 gap per megawatt hour. And the way you close that gap is you have the various tools available of cost share, production tax credits for advanced nuclear, the DOE Loan Guarantee Program Office, and then potentially PPAs being the next increment of how you close that gap. But that's what we're really focused on at NuScale, of using all those tools that are available to make sure we can close that gap so that the first customer isn't paying a penalty for being first. When we have a conversation with countries such as Jordan, Saudi Arabia, Slovak Republic, Czech Republic, they come away very impressed with the U.S. technology, not just ours, other folks as well. The next question they ask is, when is it going to be ready? When are you going to have one operating in the United States? Our answer is 2026, a little bit of a groan. The third question is, okay, can you guys bring some financing with that? And that's just the really, for lack of a better term, the buzzkill in the conversation, because up to that point, they're generally very excited about the technology, they're very excited about the safety, and they're very keen to have, seeing it being demonstrated in the United States. I think with the BUILD Act, presuming that the prohibition on nuclear is not carried over from OPIC, will be a great leveler for U.S. industry. It doesn't need to be 100% U.S. financing, just like you don't need 100% of the output from Department of Energy going to PPAs. You just need a piece of it to give that confidence and comfort to people that the U.S. government is there, because people want our technology. We just have to make it easier for them to get it.
I was struck by the very clear articulation by the national or the federal government about how they view nuclear, which is they say it in the roadmap, but then they repeatedly say at the conference where they launched the roadmap that nuclear energy is their strategic asset. Now, Canada has a lot of uranium mining industry as well as, fuel fabrication. They do not enrich uranium, from what I understand, because CANDU design uses natural uranium. But they do have the supply chain, the cycle that they do see as industry that makes the country very competitive. They also look at nuclear's benefits. Clearly not just the economic and job creation benefits, but they clearly articulate that it has climate benefit as well. So the way that they really put the focus, clear focus, but then also try to then have this Team Canada approach, not just the federal government, but they included a lot of provincial governments that are interested in the potential of small advanced nuclear for remote location or mining industry or heat to use use it as a heat source. And then have this, close relationship among the government, industry, and their national nuclear lab.
I have to say something about Canada. I give them a lot of credit, but I would say all the pieces that they've been able to put together, we have. So I don't think they're not inventing something that we don't have up there. It's just a question of, I think, focus. That would be my only comment, I'd say.
And we need to get better at marketing ourselves, as you've said.
I'm not allowed to use that word. But
Okay, I'm sorry. Right, not marketing. Expressing your technical capabilities.
Expressing our technical capabilities.
Yes,
Yes,
right,
thank
yeah.
you.